Hello everyone, this video series is all about SAT math hacks where we discuss smart tricks and strategies to solve SAT math problems. In this video, I am going to cover hack number 1, which says find only what you need to. Here's what that looks like. Look at this question number 1 here, which says if root of 5 is equal to x plus 3, what is the value of x plus 3 whole square? Now, if you were to take the traditional approach, you would first find x from this equation. You would say x is equal to root of 5 minus 3, and then you might substitute that here to find x plus 3 whole square. But remember the hack, find only what you need to. And in this case, what that means is that you already have the value of x plus 3. X plus 3 is equal to root of 5. And what you really need to find is x plus 3 whole square. So if x plus 3 is equal to root of 5, then you don't need to find x on its own. You just square this expression. So you say x plus 3 whole square will be equal to root of 5 square, which will be equal to 5, and that's it. Find only what you need to. So the answer in this case is 5. Now let's look at this second question here, which says if 3y minus 5 is equal to 10, what is the value of 3y plus 7? So once again, typically a student might try and find the value of y from this equation and then substitute that back here into this expression to find the value of 3y plus 7. But find only what you need to. What you can notice here is that you have 3y minus 5 equal to 10. So 3y minus 5, this is given to be equal to 10. And what you need to find is 3y plus 7. So this 3y term here is common, and you just need to convert this minus 5 to a plus 7 to get the value you desire. So all you need to do here is just add something here that converts this minus 5 to a plus 7, and that something is 12, because minus 5 plus 12 is plus 7. So we add 12 on both sides, and that simply gives us 3y plus 7 is equal to 22. So that's it, 22 is our answer in this case. So find only what you need to. You did not need to find the value of y in this case, you just needed to find the value of 3y plus 7. Now let's take a look at this third question, which says if 3 by 2 minus 5x is equal to 7, what is the value of 15 minus 50x? So once again, the typical traditional way would be to solve this equation and find the value of x and then substitute that into this expression to find the value of this expression. But what we'll do is we'll see if we can directly modify this equation to get the desired value. So the equation given to us is 3 by 2 minus 5x is equal to 7, and what we notice is that this 15 here and this 50 here, these two numbers are the same multiple of 3 by 2 and 5. In fact, if you multiply 3 by 2 by 10, you will get 15, because 3 by 2 times 10 will be 3 into 5 or 15. If you multiply 5 by 10, you will get 50. So all we need to do in this case is just multiply both sides of this equation by 10. So I'll multiply the left hand right side of the equation by 10. So on the left side, I'll get 10 into 3 by 2, which is 15, minus 10 into 5x, which is 50x. So 15 minus 50x, the expression I was looking for, this is equal to 70. And that's it, I'm done. The value of this expression is 70. So find only what you need to. In this case, you did not need to find the value of x, you needed to find the value of this expression. So just by modifying this given equation, multiplying it by 10 on both sides, we get the desired value. The next question says, if c is not equal to 0 and 2a plus c by c is equal to 5 by 2, what is the value of a by c? So once again, find only what you need to. You don't need to find the values of a and c separately. In fact, you can't do that because you just have a single equation, but you have two variables. what you need to find is the value of this ratio A by C. So, what you can do here is this 2A plus C over C, you can write it as 2A by C plus C by C. So, you are separating the two terms in the numerator. So, 2A by C plus C by C is equal to 5 by 2, and what does that give you? So, C by C is 1. So, from here you get 2 times A by C, which is A by C is what you are really looking for, plus 1 is equal to 5 by 2. So, now you subtract 1 on both sides, or in other words you take this 1 over to the right side. So, you get twice of A by C is equal to 5 by 2 minus 1, which is 3 by 2, and then from here you can finally find the value of A by C. You divide both sides by 2 and this gives you A by C is equal to 3 by 2 divided by 2, which is equal to 3 by 4. So, once again find only what you need to. You did not need to find the values of A and C in this case, and in fact you can't in this case. What you needed to find was A by C, and just by separating out the terms here you can actually find that very easily. Alright, now here is the next question. For a function f of x equal to x plus 5 by 4, what is the value of f of 9 minus f of 1? So, one approach here could be you find f of 9 separately, you find f of 1 separately, and then you take the difference and that is your answer. But once again find only what you need to. So, what we observe here is that f of x is actually equal to x plus 5 by 4. So, we separate the two terms in the numerator and we write it as x by 4 plus 5 by 4, and what this means is that f of 9 is equal to, instead of x I write 9, so 9 by 4 plus 5 by 4, and f of 1, the other term, the term I have to subtract, f of 1 is equal to 1 by 4 plus 5 by 4. And now if I take the difference, in this case if I take the difference of f of 9 and f of 1, I can see that it will be this minus this. So, this constant term 5 by 4, 5 by 4, this will cancel out from the two expressions. So, my difference will be 9 by 4 minus 1 by 4, 9 by 4 minus 1 by 4, which is 8 by 4, which is equal to 2. So, the answer in this case is 2. Now, I think in this case you could have actually calculated f of 9 and f of 1 separately and taken the difference, but once again this illustrates the technique that what you really need to find here is not f of 9 and f of 1 separately. You needed to find their difference, and therefore you could have done that in this way. And in this case the calculations were simple, but sometimes they are really hard. But if you just focus on what you need to find, the simplification becomes easy. Okay, and then here's a last question for this video, which says this is a pair of linear equations, 6x minus 9y is minus 42, 7x minus 10y is 5. If x comma y represents a solution to this system of equations, what is the value of x minus y? So, once again the traditional approach here would be that you solve this pair of linear equations by elimination or substitution or graphing the two equations. You find the values of x and y and then you calculate x minus y, but find only what you need to. What you need to find is not x and y separately, what you need to find is x minus y. So, if you focus on these expressions on the left side, 6x minus 9y, 7x minus 10y, you find that the coefficients of x, they differ by just 1, 7 and 6, and the coefficients of y, minus 10 and minus 9, they also differ by 1. So, perhaps if I use these two equations in some combination, specifically if I subtract these two equations from each other, I might get what I am looking for. So, what I will do is, if I call this my first equation and I call this my second equation, so I will subtract the first equation from the second equation. So, let me write that here. So, my second equation is 7x minus 10y is 5, and the first equation is 6x minus 9y is minus 42, and now I am going to subtract this. So, 7x, so I will put a minus sign here. So, 7x minus 6x is x. So, let me write that here. and then minus 10y, and then this minus 9y will become plus 9y. So, minus 10y plus 9y will become minus y. So, x minus y on the left side, and then on the right side I will get 5 minus minus 42, that will be 5 plus 42 or 47. So, that is it. I get the value that I was trying to find, x minus y, that is equal to 47. So, you did not need to find x and y separately. Just by subtracting the two equations, you get the value that you are looking for. So, that is hack number 1, find only what you need to. I hope you liked it. Let me know what you think in the comments.